Thank you. Could you go back 2 slides? One more. No, there's a good start because, ladies and gentlemen, you can note my email address and I will welcome hearing from you. Next slide, please. And the next slide, please. I'm honored to be speaking at a symposium in memory of Tony Naldrett because I published a book about travels with Dr. Naldrett in Norilsk and to the Voisey's Bay nickel-copper-cobalt project in Labrador. Voisey's Bay, the next slide please, was a brilliant greenfields exploration success under Robert Friedland in the mid-1990s. And it's, next slide, it's a case study for 6 different applications of net smelter returns, or NSRs. And today I'm going to focus on point 2 and show you why geologists should use NSRs to model nickel mineralization. Then I'll address point 3 and show you that you can use NSRs to finance exploration, although I have an alternative that's even better. But I'll start with a cautionary tale that relates to point 4. The prospectors who discovered Voisey's Bay took back a 3% NSR royalty from a mining company that's today owned by Brazil's Vale SA. And the prospectors sold their NSR to 2 royalty companies, which in October '09 filed suit against Vale, claiming underpayment of past royalties totaling $29 million US. And the lawsuit hinged on the definition of the term NSR, and it continued for 9 years. I'm familiar with the lawsuit because one of the lawyers involved Googled definition of NSR, and up popped a chapter of a textbook that I published in 1991. Next slide, please. My co-author, Peter Treasure, and I had pointed out that an NSR, a net smelter return, is what the mine gets paid for the mineral products that it sends to a smelter, taking into account not only smelting, refining, and other fees, but also that smelters don't pay you for all the metals that the mine delivers to them. And since 1991, I've continued to model NSRs. I monitor smelting and refining contracts and metallurgical data from base metal mills around the world. And I organize this information in Excel spreadsheets. I make these spreadsheets freely available, and you can use them to estimate NSRs. In communicating with a company's management, with its board of directors, with its regulatory officers, and with its investors, some geologists are known to aggregate assays into nickel equivalents or grams per ton total precious metals. And I argue against these measures. They're very misleading, not only because the relative prices of metals vary wildly, but also because the recovery rates and the smelting and refining fees of each metal are very different. To aggregate assays, geologists use NSRs. NSRs are expressed in dollars. The most important unit of measurement of grade for the economic geologist, it's not percent, it's not grams per ton, it is dollars. Dollars are a universal language for economic geologists to communicate not only with the rest of the world, but with each other. When you're modeling polymetallic mineralization, use estimates of NSRs. You can Krieg them, you can use them in determining cutoff grades, and you can use them in determining geometallurgical domains. And by constructing and maintaining NSR models of mineral deposits, geologists are forced to address a number of factors that might determine whether or not a deposit could become an ore body. To use NSRs in exploring a polymetallic nickel sulfide deposit, put yourself in a position of a mine geologist. Estimate the value of a drill core assay as if it were a block of mineralization in an operating mine. Now, in the next slide, you'll see that a mine's mill typically will separate valuable minerals in the form of concentrates, which are sent off to a smelter. The usual process of mineral separation is differential flotation, where you blow bubbles through a mixture of water, pulverized ore, and reagents. Most economic minerals, and in this case chalcopyrite, have metallic surface properties, and they attach themselves to those bubbles, and they're concentrated into a froth, which is skimmed off and dried and sent out to make a concentrate. But some metallic minerals do not have metallic surface properties. Next slide, please. Economic geologists should look out for these minerals. Processing them could even be impossible. For example, you cannot economically get nickel out of olivine. Voisey's Bay concentrates get paid for just 3 metals: nickel, copper, and cobalt. But as we've heard today, many other nickel, copper, cobalt sulfides also contain significant gold, silver, and platinum group metals. Next slide, please. And yet almost all of the precious metal credits paid to a nickel miner are from silver, gold, platinum, and palladium. Now, I understand that Glencore and Vale both extract iridium, osmium, and ruthenium from ores at Sudbury, but they keep that quiet. It's unlikely that an outside miner would get paid for them. Rhodium. Rhodium prices just this week crept over $12,000 an ounce. $12,000. Maybe they would, the smelter would pay you for it if you negotiated your deal with them hard before you started sending out product. But if you're keen on getting credit for iridium, osmium, ruthenium, and rhodium, check how these metals occur on your property. As Eduardo's presentation indicated, these 4 metals tend to be associated with pyrrhotite, and pyrrhotite is a mineral that many mills reject to improve the salability of their concentrate. Let's go through an exercise in modeling with NSRs. Use the next slide, please. Treat this as an assay. And I've estimated 2 measures of this mineralization, an NSR and a netback. Next slide, please. A netback is the NSR expressed as a percentage of the gross value of metals contained in an ore. And in the next slide, you can see the results of this analysis. As you can see, for the assay that we're modeling, the estimated netback is 45.4% of the gross metal content. If you were to exclude iridium, osmium, ruthenium, and rhodium from the gross value, you could boost that figure to 48%, but it's still sobering to know that the ore produced by a typical nickel mine contributes to that mine's net revenues less than half of the net in situ value of the metals that the miners have dug out of the ground. Now, most nickel sulfide mills make either 2 concentrates, a copper one and a nickel one, or a single bulk nickel copper concentrate. The figures in this calculation assume the production of 2 concentrates. Had there been a single bulk one, it would have given a lower netback, 41.7%. So if you're modeling NSRs, should you assume 1 concentrate or 2? And there's lots of moving parts in answering that question. For example, the capital and operating costs are likely to be higher for a mill producing 2 concentrates. And a lot depends on who buys your concentrates. At Sudbury, Glencore's operations are better set up to receive 2 concentrates and Vale's 1. But Glencore is usually able to recover and pay for a greater percentage of the cobalt that you send them. And that could be enough to tip your preference to Glencore smelters and to your producing 2 concentrates. So a geologist's modeling of a nickel deposit could provide 2 sets of NSRs, one assuming 2 concentrates, one assuming 1 concentrate. And the resulting range of values could help the engineers decide which scenario to choose. And another topic of conversation between geologists and engineers could be to determine the extent to which the location of the proposed mine will determine its economics. Next slide, please. Although if there is year-round access, the location of a mine may not be hugely important in determining its full economic value. Oh, and here's a topic of conversation that geologists should have with metallurgists. Next slide, please. Smelters ding miners for the nasties that they find in concentrates. If nasties are there in significant quantities, a smelter could impose penalties that seriously reduce the NSR. And one thing geologists should be aware of is if cobalt shows up in a copper concentrate, a copper smelter will generally impose penalties, not give you credits for that cobalt. And in estimating NSRs, you need to know what smelting and refining fees to include in your models. But most nickel and bulk nickel copper concentrates are smelted by the companies that produce them. So nickel smelting and refining fees are rarely publicly available. If you were to Google nickel concentrate smelting and refining fees, you'll probably find nothing that's current. And yet, potential smelting and refining fees become very important if a company decides that to fund its exploration, it's going to sell an NSR royalty. But the smelting and refining fees are confidential. So what do you do? Well, you could use my Excel models, and the company's management could start conversations with people from smelting and refining companies that might be interested in taking the future mines products as feedstock. But for the purpose of financing exploration, there is an alternative to NSRs, and it's better than NSRs. Next slide, please. Note that CONIC is starting to use another form of royalty, the GRR, or gross revenue royalty. I think the GRRs are the royalties least likely to attract lawsuits. GRRs are a percentage of the gross value of metals contained in the products as they go out the mine gate. No confidential smelting fees, no deductions. Next slide, please. For mineralization with a netback of 45%, as we've seen, that's a typical number, a 1% gross revenue royalty would be worth, let's look at the next slide, would be worth about the same as a 2.2% NSRs. But there is a disadvantage to NSRs that also applies to gross royalties, and that is the possible presence of nasties. If an exploration company were to sell a royalty during the early stages of exploration, it would be prudent to insert clauses into the company's agreement that recognize that the presence of deleterious materials may reduce the ability of the operator of the future mine to generate the cash to pay out on the royalty. Next slide, please. That's the kind of clause that should be considered inserted in your funding agreement. So in this presentation, I've been encouraging geologists to use NSRs in modeling mineralization. In some cases, the numbers that NSR modeling produces can be very rough. But NSR models do show you what questions geologists should be asking of engineers, of management, and of each other. And if your NSR models give you a feel for the language used by people who run royalty financing companies, here's a list of publicly traded companies that you can call, next slide please, if you're interested in selling a royalty to finance exploration on your product, on your property. And that will end my presentation.